Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to find the position, velocity, speed, and acceleration at a particular time given a position function. Alright, the instructions are as follows. A particle moves along a horizontal line. Its position function s of t for t greater than 0. That's the position function. For each problem, find the position, velocity, speed, and acceleration at the given value for t. If the time is measured in seconds and position in meters, determine if the particle is slowing down or speeding up at the specified time value. Okay? Alright, so for number 1, the example we're going over, let's say that we are given the position function negative t to the third plus 18t squared minus 81t, and the time that we're looking at is at t equals 2. Okay? Alright, so let's do the first part. The first part, we're to find the position at this time. Okay? So we want to find the position at t equals 2. Another way of expressing this using mathematical notation, position at t equals 2 is s of 2. So one thing you want to note is that s does not mean speed. Common confusion. S represents position. Okay? Alright, so let's go ahead and do that. Now, where are we starting from? What are we given in this particular problem? In this particular problem, we're given the position function. So we're given s of t, which is negative t to the third plus 18t squared minus 81t. So what do we do with this function? Are we going to be do we have to evaluate, integrate, or differentiate? That's the question. So given s of t, we want to find the position at t equals 2. Are we going to evaluate, integrate, or differentiate? Since we already have the function that we need, all we're just simply going to do is evaluate. Okay, so that's the step for this particular one. So we're going to evaluate. We're going to evaluate this position function at the specified time. So we're going to evaluate s at t equals 2. So just simply plug in 2 for all the t's. So we have negative 2 to the third plus 18 times 2 squared minus 81 times 2. Alright? Okay, now we'll just use order of operations to simplify this completely. Negative 2 to the third is going to be negative 8 plus 18 times 4 is 72 minus 162. And then when we simplify it, s of 2 is negative 98. And the unit for position is meters. Alright? So let's write down what the answer means. The position of the particle at t equals 2 is negative 98. So this negative basically means you're either going to the left 98 meters. Alright, next we want to find the velocity. Okay, so part B, we want to find the velocity at t equals 2. Another way to write this, the velocity at t equals 2, is just to write v of 2. V of 2. Okay? Alright, let's go ahead and do that. Now, let's see. How do we find velocity if we're given the position function? To help us do that, we're going to use our SIVA acronym, or SIVA continuum, that we talked about in the previous tutorial in this series. SIVA should help us see the connection. Alright, so let's write it down. It could be S or X, it doesn't matter, but in this case it's S, SVA. Position, velocity, acceleration. Okay, we already know position is in meters. Now if you want to go from position to velocity, so given position, if you want to find velocity, you're going down the Siva continuum. Every step down is a derivative. Okay, so in this case we are going to have to differentiate. What this Siva continuum tells us is the formula for determining what the velocity is going to be. Alright, so the formula for velocity at any time t, v of t is equal to the derivative of the position. Okay. Alright, so in this particular problem, we're not just looking for v of t as we did in the previous tutorial. In this presentation, we're looking for the velocity evaluated at a particular point. So that means we're going to have to evaluate the derivative of the position at that point too. Now, anytime you're evaluating the derivative, that's a 2-in-1 problem. Okay? So if you're differentiating and then evaluating, it's beneficial to separate your work. So you do the differentiation step first. So we're going to find the velocity function by differentiating the position. Very, very important. You differentiate first and then you do the second step, which is your evaluation step. You do your calculus before you do your arithmetic. So you evaluate v of 2, which is basically s prime of 2. Alright, we're going to start with the first part, part 1, which will involve us finding, we're going to find the velocity v of t, which is equal to s prime of t. Okay? Alright, what are we given in this case? We are given the position function s of t, which is negative t to the third plus 18t squared minus 81t. Okay? So as we talked about from Siva here, in order to find the velocity, the step is to differentiate. So we're going to be differentiating. Okay, so our velocity function v of t is going to be, so v of t is going to be the derivative of our position function. So we just differentiate both sides. Alrighty, so let's go ahead and differentiate. V of t is equal to s prime of t, which is term by term differentiation, negative 3t squared plus 36t minus 81. Okay? Now the next part is to evaluate the velocity at the specified time. So for part 2, we're going to evaluate v of 2, which is the same thing as s prime of 2. Okay, so v of 2, well, we're given, what are we given here? We know what v of t2 is. We already found it. So v of t is negative 3t squared plus 36t minus 81. Now to find v of 2, we're simply just going to evaluate. Okay, so v of 2 is going to be negative 3 times 2 squared plus 36 times 2 minus 81. If you do the calculations, using the order of operations, we'll have negative 12 plus 72 minus 81. And then this simplifies down to negative 21. for the velocity at t equals 2 meters per second. Okay, so what does this mean? This basically means that the velocity at t equals 2 is negative 21 meters per second. Alright, so next we have to find the speed. Let's go ahead and find the speed, part C, at t equals 2. So I want to find the speed at t equals 2. Alright, so the formula for speed is as follows. Speed is simply the absolute value of velocity. Okay, so if we want to find the speed at t equals 2, all we just do is we take the absolute value of the previous answer we got, absolute value of negative 21, which is the velocity. So the speed is 21 meters per second. Alright, next we're going to have to find the acceleration at t equals 2. Now it's very similar to what we did here with the velocity component. So I'm going to put it right here, right next to it, so we can compare the steps and see how similar they are. Okay? So with the acceleration, we have to ask ourselves, how do we find the acceleration? We want to find the acceleration at t equals 2. Okay, the acceleration at t equals 2 is the same thing as a of 2. That's what we are looking for in this part. Alright, so let's start off by writing down what the formula is. Formula for calculating acceleration. So the formula is what? So if we go back to CVA again, CVA, if you want to find the acceleration from velocity, you're just simply going to differentiate. Okay, remember, from position to velocity we differentiate, and if you're going from velocity to acceleration, you differentiate again. So the formula here is as follows: acceleration is equal to the derivative of velocity. Alrighty, and you can also find the acceleration from position. All you have to do is differentiate twice. If you were going from, let's say, position directly to acceleration, what you're going to do is find the second derivative of position. Okay? Alright, now let's get started. We want to find a of 2. So we're going to use the velocity, okay, since we already have it. The acceleration at 2 is going to be the velocity v prime of 2. And this is a 2-in-1. Okay, the first part, we're going to have to find the acceleration. The acceleration is the derivative of velocity. So a of t is equal to v prime of t. You differentiate first, okay? After you differentiate, then you evaluate. Alright, so you evaluate the acceleration at t equals 2, which is the same thing as the velocity, differentiated, evaluated at t equals 2. Alright? Okay, so let's do the first part. We want to find the acceleration function. To do that, we're going to differentiate the velocity. Okay? So given the velocity function v of t, which we found before to be negative 3t squared plus 36t minus 81, we're going to differentiate to find the acceleration. Just as we differentiated position to get velocity, we're going to differentiate velocity to get acceleration. Alright, so we have a of t is going to be v prime of t. just as we did right here. Okay, so that means we're going to be differentiating negative 3t squared plus 36t minus 81 prime. So a of t, which is the velocity differentiated, is equal to negative 6t plus 36, and then the derivative of 81 is 0. Alright, so that's the differentiation step like we did with the velocity. The next step is the evaluation step. Alright, it's the algebra step. So we want to evaluate the acceleration at 2, which is the same thing as v prime of 2. So to do that, let's see where we're starting from. We know what the acceleration is already. So the acceleration is negative 6t plus 36. So we're going to evaluate it at 2. So simply plug in 2 into the acceleration function. Okay, and then you use order of operations. You get negative 12 plus 36. And then your acceleration is going to be 24. And the unit for acceleration is meters per second square. Okay, so the particle's acceleration at t equals 2 is 24 meters per second square. Okay, now the last question is the particle speeding up or slowing down? All we just have to do is compare the signs of the velocity and acceleration at t equals 2. Okay, the signs are different, so we know that the particle is going to be slowing down. If their signs were the same, then it's speeding up. Alright, so part E, we know that v of 2 is negative 21 and a of 2 is 24. So we just write since v of 2, velocity at t equals 2, and a of 2, acceleration at t equals 2, have different signs, that's a slowdown. Okay, have different signs, and the particle is slowing down. Okay, so that's that. Thanks so much for taking the time to watch this presentation. I really appreciate it. We'd like to know what you think. If you found the contents of this tutorial helpful in your studies of position, velocity, acceleration, do give us a thumbs up. Your positive feedback is very valuable to us. For questions, comments, or requests, just post it in the comment section below and we'll be glad to respond. Don't forget to subscribe to our channel for updates to other presentations such as this. More support resources can be found at math.serve.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.